Here's the next question, number 32. For the switching converter shown in the following figure, assume steady state operation. Also assume that the components are ideal, the inductor current is always positive, and continuous and switching period is Ts. If the voltage VL is as shown, the duty cycle of the switch is dash. Alright, so let's first write down what is the condition in order for the system to be continuous. Now for continuous conduction, we must note that the average inductor voltage is always 0 in this case. So I'll write that down here first. For continuous conduction, the average inductor voltage VL is 0. Now, according to the graph given here, see we have a tiny cute little graph there. So let's write down the voltage equation for the figure given. So VL is equal to Vp into T divided by Ts. Please note this general equation here. The inductor voltage is equal to the peak voltage given times the ratio of T divided by Ts. While this T here, it's T on and T off for two different half cycles. So using this expression, let's write down the voltage equation for this, looking at this graph here. Okay. So VL would be equal to, Vp is the value 15. So first we are going to look at this portion here. Okay. So that's 15 into the ratio T on by Ts plus, now for the negative half cycle. So that's minus 45. That's the value of the voltage given here, into the ratio T off divided by Ts. Now this entire thing is equal to 0 according to the condition of it being continuous in conduction. Okay. So now let's write down the expression further. We have VL is equal to 15 T on by Ts minus 45 T off by Ts is equal to 0. Now we can write this as 15 T on minus 45 T off is equal to 0. Further, 15 T on is equal to 45 T off. And the ratio of T off by T on is 1 by 3. That's 15 by 45, 1 by 3. Or either way, you can write the ratio as T on by T off as well as 3 by 1. It doesn't really matter which one you take, because either way the next step is to find out the value of the duty cycle. Okay, so we will use either one. Now the duty cycle delta is given by the expression T on divided by T on plus T off. Note this equation as well, quite important. Delta is equal to T on by T on plus T off. Now, using the ratio given, the ratio that we have just found, we can find out what this is. Now, T on divided by T on plus T off, we can write this as 3, I'm going to use this portion here, see, 3 divided by T on plus T off would be 1 plus 3. I hope that makes sense. Now, this is 3 by 4. And that gives us a delta value of 0.75. So here this is our final answer, 0.75. So this is the entire solution and I hope it has helped.